Okay, in continue of our lecture on K-map, in this lecture I will talk about the minimal product of some form of K-map. Minimal product of some form from K-map. Sometimes it's easier for like a designer, an engineer, to implement the product of some form of a function rather than sum of the product. Okay, so sometimes it's easier to implement product of sum. So in order to implement the product of sum form, which if you remember, we said that sum of products can be implemented by NOR gate, and the product of sum can be implemented by NAND gate. So if the designer wants to implement the circuit with the product of sum, he or she has to deal with K-map in the form of product of sum. Some steps are involved to simplifying the function, to simplify the function in K-map using like to the form of a product of sum. These steps are as follow. First step, we plot f on K-map as we did for sum of product. Second step, this time we group zeros. If you remember, for sum of product we grouped ones, but for product of sum we group zeros. Grouping zeros follow the same rules. Follow the same rules that we used earlier in grouping of ones. Okay, same rules. Step 3, write product of sum directly from K-map. So the main difference is that we group zeros instead of ones. So let's see some examples. Example, find minimum cost product of sum for this function f of a, b, c, d is equal to sigma m 4, 5, 7, 8, 10, 11, 12, 13, and 15. These are the min terms, so these are ones, not zeros. Let's plot the, let's draw the table. Okay. Okay, let me copy this. I'm just trying to copy it for our next example. Okay, so let's fill the table with ones. So it's 1, 1, 1, 1, 1, 1, 1, 1, 1. Of course, the other cells are 0. And because we want to implement or find the POS form of the function, we need to group zeros instead of ones. So we get these 4 zeros, we get these 2 zeros together, and of course we can get these 2 zeros. And now we write the uh, function. One difference between sum of the product and product of sum is that for sum of products, when we have 1 for the literal, we say this one is A for sum of product, for sum of product. But for product of sum, it is A bar because we're dealing with zeros and it's complement of product of sum. Uh, so we can say the middle two columns are considered as B bar. Of course, the B is 1, but we say it's B bar because we're finding product of sum. The middle two rows here are D bar. The last two rows here are C bar, and the last two columns are A bar. Okay, and now it's time to write the function. So function is equal to first the red one. The red one, A and B are 0, 0, so we say A, B, C and D are changing, so are cancelled. So we say A plus B because we're writing the product of sum, not sum of the product. So be careful. In sum of products, we say AB, but in product of sum, we say A plus B times the given one, the given group. If we look to the given group, A is changing, B is constant, which is B bar plus C is constant, it's C bar, D is constant, D. Okay? And plus the blue group, A is changing, B is constant, so it's not plus, sorry, it's time. B is constant, so it's B, C is constant, so it's plus C plus D bar. And this one is a product of some form of the function. Let's do one more example. Minimum cost product of sum. F of A, B, C, D is equal to sigma of min terms 0, 1, 2, 5, 8, 9, and 10. Of course, we know that the sigma of min terms is equal to the product of the max terms which are not like these numbers. Okay, so we can say the product of max terms of 3, 4, 6, 7, 11, 12, 13, 14, and 15. Okay, so any term that is min term cannot be max term, and any term which is max term cannot be the min term. So we just ignore the min terms. The other like combinations are max terms. Okay, so we can just complete the table using this information if I want to use this one, I should put one, fill ones. If I use this one, I fill with zero. Okay, both give the same result. So there is no difference if I try to uh, fill the table with product of max terms or sum of min terms. Okay, so the only thing is that if I'm using this one, I fill the table with 1. If I'm using this one, I fill the table by 0. Let's use max terms here. So number 3 is 0, this one is 0, 0, 0, 0, 0, 0, 0, 0. Of course, the rest of the cells are 1. So we want to group them. So this is the first group. Why we grouping zeros? Because the problem asking us to find the product of sum. This is one group. The second group is here. Third group, the easiest one of course is this one and this one. Is it correct? Yes, but still it is not the like biggest group. What should we do? Let's consider these two together with these two. Now we keep the group as big as possible. So function is equal to the red one. A and B are changing. C and D is C bar plus D bar. The green one, C and D changing. It's A bar plus B bar. The black one, A is changing, B is constant, so it's B bar. C is changing, D is constant, plus D. And so this one is the minimum product of sum. Okay, one thing that we should know is that like minimal product of some form of function is the complement of the minimal sum of product form of function val, the complement of the function, and minimal sum of product form of function is equal to complement of minimal product of some form of f bar. Okay, so in logic expression, if we cover ones, we will get minimal sum of product form. If we cover zeros, we will have minimal product of sum form. Okay, so this one is the solution. For example, in this example, if we complement it twice, we will have CD plus AB plus BD bar, which is the complement of sum of product. So what does it mean? It means that if in this table we considered ones instead of zeros, the function would be equal to CD plus AB plus BD bar. And if you see, the complement of this function is equal to product of sum. So it's very important to know the relationship between sum of product and product of sum. Okay, so this lecture was about K-map in the form of product of sum.